In this section, we're going to take a look at two different types of formulas, the sum to product, and then also the sum to product and the product to sum, meaning rewriting things that are in a state of multiplication, so a product, and rewriting it as a sum, and then vice versa. So these are the sum to product to sum. So we have multiplications going on here: cosine x, cosine y. So the cosine of two different angles, and then we are rewriting them in terms of rewriting them so that they are a statement of addition. And so we have these. Let's take a look at a couple of ways that we could apply this. So we start off with finding the exact value for sine of 75, sine of 15. We can't get an exact value using the values that we have there, but when we rewrite this as taking it from a product to a difference, in this case, we're going to be able to subtract and add those two values together. So that's one thing, is we're taking the angles and we're turning them into new angles. So in rewriting this, we just want to kind of use the formula that we have there. That gives me cosine of 75 minus 15 minus the cosine of 75 plus 15. And 75 minus 15 gives us one of our special cosine values, 60. And if we add those two together, we get 90, which is another known exact value for cosine. Cosine of 60 degrees gives us 1/2, so that gives me 1/2. And the cosine at 90 degrees, cosine being the x value at 90 degrees, is 0. And 1/2 minus 0 is just 1/2. So we have 1/2 times 1/2. So that takes us down to 1/4. Here's another example. We're going to find the exact value of cosine 75, sine of 15. So we use the cosine times sine formula. That gives me sine of the sum, so 75 plus 15, minus the sine of the difference, so 75 minus 15. So that gives me 1/2 times the sine of 90 degrees minus the sine of 60 degrees. The sine at 90 degrees is actually 1, and the sine at 60 degrees is √3/2. So if we think of 1 as being 2/2, that we can combine those together. The top just remains a difference, 2 minus the square root of 3. And then we carry over that 2, but then we have this multiplied by 1/2. So that gives me 2 minus the square root of 3/4. And this, though it's a statement of subtraction on top, it's still an exact value for the sine of 75 and the sine of 15. Here we have, again, changing it from one form to another form. At this time, we're going to go the other way around. Notice that the x and y's would be different angles, or they could be the same. But assuming they're different here, we're adding up those, dividing by 2. So then we're taking the cosine of a new angle. And some of these have sine as well. So let's take a look at a couple ways that we could apply this. Our first one is going to be rewriting the sine of 4 theta minus the sine of 6 theta. And then we'll take b on next. So it's a subtraction of two angles, right? And so in applying the this difference, or this, you can think of it as a sum, but like plus a negative, right? We can rewrite this so that the angles are different. This would be 2 sine, then we have 4 theta minus 6 theta. 4 theta minus 6 theta. We just use our formulas here. This is what we're taking the sine of, and then we're going to multiply by the cosine of the sum of those. So 4 theta plus 6 theta all over 2. So this is 2 sine. 4 theta minus 6 theta is negative 2 theta over 2 times the cosine of 10 theta over 2. Of course, we can simplify what's inside those parentheses. So taking that 2 into the top here, and we can make that into a 5. So this gives me 2 sine of negative theta times the cosine of 5 theta. And we can take it a little bit longer too, because sine is an odd identity. So if we take the sine, if you remember, the sine of negative x results, and when we take the negative x, we get the opposite. So we get the negative sine of x. So I can actually just sort of bring that negative and put it out with the 2 and say this is equal to 2 sine of theta times the cosine 5 theta. And we've simplified it. Let's actually try doing this with b, the part that we want us to do second, where we have some actual values here, 65 and 55. And we're just going to take it as far as we can. Applying this formula. So this is 2 cosine of 65 plus 55 over 2 times another cosine of the difference, so 65 minus 55 all over 2. All right, well, 65 plus 55 gives us 120, so this is 2 cosine 120 over 2 times the cosine of 10 over 2. And 120 over 2 is 60, so that's 2 cosine of 60 degrees. Multiply the cosine of 5 degrees. Now, 5 degrees isn't a special formula that we have, so we just have to leave it like that. Cosine, the x for 60 degrees is 1/2. So that's 2 times 1/2. And 2 times 1/2, of course, is just 1. So we have 1 times the cosine of 5 degrees. So cosine 5 degrees. Before we go to the next one, I want just us to notice here that these all involve the same, like cosine plus a cosine minus a cosine, sine plus a sine minus a sine. So there's no mixing of those up. So in this next one, they present us with one where we have a combination. We have a sine with a cosine being added. And you say, okay, well, how can we do this? Well, remember that cosine and sine have a relationship. They're both, x and y unit values, and we see their values switch. And so sine can actually be rewritten as a cosine using some earlier identities that we talked about, where sine is the same as the cosine of a value if we take it 90 minus that value. So in this case, it will be cosine of pi over 2 minus 50. So rewriting this as two cosines, that would give me cosine of pi over 2, 90 degrees, minus 5 theta, plus another cosine of 3 theta. And we could have done this, a similar thing, we could have turned them into two sines by rewriting the cosine as a sine. But that can be done. And then this is just a matter of simplifying and filling it into our formula up here. Oops, I forgot the... Nope, I didn't forget anything. So now I'm going to use this formula. That's 2 cosine. And this is a little tricky because we have a fraction within a fraction. With that pi over 2, so pi over 2 minus 5 theta. That's our first thing. And then we add 3 theta. And that's all over 2. So here this is the first, angle value there. Pi over 2 minus 5 theta. Then we add it to the y, which was the 3 theta. And now we multiply that by the cosine of the difference of those. So pi over 2 minus 5 theta minus 3 theta all over 2. All right, and then simplifying this in here, we have a negative 5 theta plus a 3 theta. So those can be combined together as pi over 2 minus 2 theta. Negative 5 plus 3 gives me negative 2. And combining these two together, that's going to give me negative 8 theta. So pi over 2 minus 8 theta all over 2. And, dividing by 2 is essentially distributing a 1/2 or multiplying by a half. So let's just get rid of those fractions within fractions by multiplying the top two values by a half. That would give me pi over 4. 1/2 times 2 theta is me with theta. Cosine, this would give me, again, pi over 4 minus, and then 1/2 times 8 is 4 theta. And so we have expressed what was an addition involving sine and cosine as a statement of multiplication or a product involving new angles once we put some sort of theta value in there, of course. Now we're going to try to verify an identity. We've got two sines being added on top and two cosines being subtracted on bottom. But notice what we're taking the sine and the cosine of is the same angle, right? 5 theta and 9 theta. So, and we're going to try to rewrite this so that it is essentially a cotangent to theta. So using the sine functions here for the sum of two sines, this would be 2 sine, and that's 5 theta plus 9 theta all over 2. Get that theta there. And then multiply by the cosine of 5 theta minus 9 theta all over 2. And that's the top part of my fraction. On the bottom, so we start out with like two sines, but notice how we don't necessarily end up with two sines with these properties. And then we have a difference of two cosine angles. This gives me negative 2 sine, the sum of them, so 5 theta plus 9 theta over 2, multiply by the sine as well of their difference. So 5 theta minus 9 theta, subtraction in there, all over 2. So simplifying the first angles, 5 plus 9 is 14, so 14 over 2. So let's simplify what we have there a little bit. On the top, we have 2 sine. 14 divided by 2 is 7, so 7 theta. And when we subtract 5 minus 9, that gives me negative 4. So negative 4 over 2 is negative 2 theta. So that's cosine of negative 2 theta. And then for the bottom, that's going to be negative 2 sine, again, 7 theta, sine negative 2 theta. Okay, so where do we go from here? Well, one thing you can notice here is that we have similar thing here and here. These are basically the same, 2 times the sine of something. So now don't forget about the negative we have here. So, but cosine and sine, of course, are not the same. So we take the negative. We have cosine of negative 2 theta on top over the negative sine of negative 2 theta. Remember, with the sine, we have an odd function. So if we go negative, it's the same. We get a negative outcome. So this negative outcome here would cancel with this negative. So actually, this gives me, and with cosine, the right up here, the cosine of negative x is just equal to the cosine of x. In other words, taking it negative doesn't change the value of the cosine. It is the same as if the angle is positive. That's because it's in the first quadrant, right? So if we go down, if we have an angle here and an angle here, the cosine values would be the same, right? They would fall at the same spot. So they would be the same no matter if it's negative or positive. It's an even thing. So I can just write that as cosine 2 theta. The bottom, the negatives kind of cancel out. We take the negative of the negative sign, right? And the negative of a negative is positive. So we just have sine of 2 theta. And cosine over sine is cotangent. So this just gives me the cotangent of 2 theta, which is what I was after here with this identity. And that gives you some types of problems there to explore in your homework using the product to sum and the sum to product identities.